Hello there. Welcome to Chemistry A, Unit 2, Periodic Table, Day 1, our lecture on the models of the atom. We will be starting off talking about the quantum mechanical model, but before we get to that, I want you to understand that what you've seen me draw on the board so far, the pictures of the nucleus with its protons and neutrons in place, and then circles drawn around the outside with electrons, is the old model. And that model is not a correct way to display that. However, when you get through here, you'll understand why it's almost impossible for me to draw the model as is represented. So let's get going with our Day 1 notes. Okay, the current model of the atom is the electron cloud model, and it is a model which is made up of atomic orbitals. Okay, if you look down here at this picture right here, you will see that that picture is a electron cloud model picture. Notice, if you remember my drawings on the board, you'll notice that I had everything pretty much, all the circles nice and evenly spaced, as best as my terrible art could be. But if you look at these orbitals right here, you will see that these orbitals are not in the center. They're more of elliptical, and sometimes the electron orbits real close to the nucleus, and then it orbits way far away from the nucleus, and that's exactly how this takes place. So atomic orbitals often are thought of as a region of space in which there is a high probability of finding those electrons. High probability. You remember probability, it's not always 100%. So probability, a high probability of finding electrons, yeah, you've got a good chance of finding electrons. The energy levels of electrons in the quantum mechanical model are labeled by principal quantum numbers. N equals 1, N equals 2, N equals 3, and so on. What you will find interesting later on is that not only do those principal quantum numbers correspond to the energy levels within the atom, they also correspond to the rows on the periodic table. In other words, elements that have one energy level, one main orbital, one principal quantum number are found in row 1 or period 1. Elements that have two energy levels are found in row 2. 3 are found in row 3, etc., etc. Interesting little fact that we'll talk about a little later on, probably in day 3 or 4 of our notes. Okay? Now, for each principal energy level, there are energy levels within that energy level. It's kind of like an onion. Onions have layers upon layers upon layers. You look at an onion, it looks like one vegetable. But when you start peeling away the onion, it's not one vegetable. It's made up of many, 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 many layers. Another analogy is the idea of Saturn. Saturn itself has what appears to be, from a distance, one main thick ring around it. However, we know that Saturn doesn't have one main ring. Saturn has many main rings in it, and it just looks like one ring. And that's the same thing with our energy levels. They have sub-energy levels, and there are energy levels and orbitals within that as well. Each energy sub-level corresponds to an orbital of a different shape, which tells where they're found. If you look at this area up in here, down here, below the picture, the orbitals, you will see the s orbital and its shape, the p orbital and its shape, the d orbital and its shape, and the f orbital and its irregular shape. These are orbitals. These are sub-levels, orbitals that are in each energy level. Okay? And this is where you can find the electrons. And as you can see, the s orbitals are spherical shape, the p orbitals are dumbbell shaped, the d orbitals are clover shaped, and the f orbitals have this irregular shape. It's shown as a cube to show you that three-dimensional geometric three-dimensional shape there, okay? So how are these orbitals arranged? Well, they stack on top of each other and in each other, and that's what gives us this goofy little thing here. As you can see, we probably have an s orbital right there, okay? And then we have these, probably what these look like are the p orbitals, okay? And they all interwove. And it's interesting because not only do they interwove, they actually, each energy level has S's, P's, D's, and F's as you go through. So we'll see that. So as we're talking here, we have energy level number 1. It has only one sub-energy level, and that is the S sub-energy level, okay? And inside that S, there's only one orbital, all right? And energy level number 2, there are 2 sub-energy levels, okay? There's the 2s, which is that spherical shape, and then there's the p, 2p orbital, which is the dumbbell shape. And interestingly enough, there are 3 small orbits within the p energy level. We go to energy level number 3, there's 3 sub-energy levels, and there are 3s, 3p, and then we introduce the d orbital. That's that cloverleaf shaped one. And it has 5 separate orbitals within that. Not 5 separate d's, but 5 separate areas where these electrons are floating around in, flying around. And then the 4, we have 4s, 4p, 4d, 4f. And we're up to 7 orbits. And it continues, it stays with 7 orbits in 5, 6, and 7, because that's the most energy levels we can have, is principal energy level number 4, okay? Now, within each principal energy level, there's a maximum of amount of electrons that it can host inside that orbital, inside that principal energy level. Much like a hotel room, much like a floor on a hotel. It only has 18 rooms in it. On that floor can hold no more. It's not like we can make a 19th floor. So as we look here, we see that principal energy level number 1, only 2 electrons in that whole energy level. And the second energy level, up to 8 total now. So that means in the 2s and the 2p can hold 8, okay? And the third energy level, right here, the third energy level, 18 electrons will be spread out through the 3s, 3p, and 3d area. And then the fourth energy level can only have 32. So there'll be 32 spread out in the 4s, the 4p, the 4d, and the 4f. And that number holds true throughout the rest of the atom. Okay? Now your assignment here is to talk about this, to read about that model right there and this model right here on pages 128 through 130. We have the Bohr model and a little bit more about the quantum mechanical model. Be ready to discuss these 2 models tomorrow.